Hey guys, how are you doing? Please let me know if you guys need anything. I want to make sure you're okay. We're still in 5.5. I just want to finish this up. I won't quiz you guys on this or test you on this because we won't be in class for that. I'm probably going to break this down into a couple days because I want to make sure they're in short bits. I tried recording this yesterday and it was like 22 minutes long for the rest of the review or the rest of the homework and stuff. And it ended up deleting it, so I'm going to redo it today and make sure that we get it into sizes that I can post. Please let me know if you have questions when they come up. I think we did these problems. 1 and 2, try it yourself. I for sure know we did. But 3, I don't remember if we did it or not, so I want to finish up with that one. So again, this is 5.5, the last part of this page packet of trig. And then we're going to go through, so we know that cosecant to the 4th of x is the same thing as 1 over sine to the 4th x. Remember that that's a trig identity. And now that we have that, we're able to use power reducing formulas. So I'm going to rewrite this. I'm going to do it down vertically again. Sine squared x squared. And we know that the sine squared, we can rewrite that in that power reducing formula as 1 minus cosine of 2 theta. I hear Michaela saying, can we just use x? Yes, we can. I'm going to try my best to stay consistent with what you guys like and what I remember you liking in class. Squared. I'm going to have to go back up here to continue it. So I have 1 over. We're going to double distribute that. So 1 minus 2 cosine 2x plus cosine squared of 2x all over, and then 2 squared is 4. Well, fraction in the denominator is the same thing as multiplying by the reciprocal, so that'd be 1 times 4 over all of that stuff. So I'm able to rewrite this as 4 over 1 minus 2 cosine squared x plus cosine squared 2x. Ooh, I put an extra squared there, but it was just a 2x. Let me go back. I'll try to make sure I'm distinguishing that, okay? 2x plus cosine squared 2x. So this is looking pretty good, but remember it's not supposed to have a power greater than 2, and so or greater than 1, and this one right here still has a square. So what I'm able to do is write another power reducing formula in there. So 4 over 1 minus 2 cosine 2x plus, and then I'm going to put that in 1 plus cosine of 2 theta all over 2. Okay, now we're, as I said, we're cooking, but that's very cliche. And we're going to keep going. So what we need to do here is create a common denominator in the denominator. So I'm going to multiply both the first two terms by 2 over 2 to create that fraction. So I'm going to have 4. And then I'm going to create everything so that's going to be over 2. So 1, I'm going to multiply by 2. The negative 2, I'm going to multiply by 2. I don't have to do anything over here because it's already as is. Correct? So plus. And then when I did this a minute ago, I put that formula in. But I did not remember something, or I did not notice when I did it. So let's talk about it now. So here, when I did this power reducing formula, the argument here was 2x. So when I put it in here, this should be 2 times 2x, which then becomes 4x for my total x here. So that becomes 1 plus, and then we have cosine of 4x. I'm able to bring it on up. Again, a fraction of the denominator flips up, becomes the numerator. So the only thing that's really moving is that 2 is going to multiply with the 4. It's going to give me an 8 in my numerator. In my denominator, I'm going to combine like terms. That's going to be this 2 and the 1. So 2 plus 1 is 3. Minus 4 cosine of 2x plus cosine of 4x. And remember that those are inside the arguments. So these would be essentially what's in your parentheses if you're putting in your calculator. Okay, so we finished our first problem. Sorry about those little hiccups there. Now we're going to go on to our next one. So example 4 is the first one we have not discussed in class of this one. There's several different approaches to begin. I began, since we just learned about power reducing formulas, to use those power reducing formulas. So I rewrote my original equation, and so I could have them in terms of squares. So I have cosine squared alpha squared minus sine squared alpha squared equals 1/2. We can substitute in what we have for our power reducing formula. So this is going to be 1 plus cosine 2 alpha over 2. And then that's all going to be squared minus 1 minus cosine 2 alpha over 2 squared equals 1/2. Okay, you got to do that double distributive property. So when we do that, you see you have 1 plus 2 cosine 2 alpha plus cosine squared 2 alpha all over 4. And over here, we're going to do the same thing. So you end up with 1 minus 2 cosine 2 alpha plus cosine squared 2 alpha all over 4 equals 1/2. I don't want to forget that. Now here's where you're noticing some things that are going to start to cancel. They both have the same denominator. Okay, so we have 1 over 4 minus 1 over 4, so these are going to go away. Well, let's try that again. Here we go, that goes away. And then you end up with 2 cosine of 2 alpha minus a negative, so that minus negative makes it a plus. So when I go over here to my top part again, I'm going to end up with 4 cosine 2 alpha over 4 still there. And then we have cosine squared 2 alpha minus cosine squared 2 alpha. So those cancel. And this is still over 4, and it still equals 1/2. You see that the 4 over 4 go away. Bam, bam. And so you have cosine of 2 alpha equals 1/2. So you're going to look and see where cosine equals 1/2. You see that cosine equals 1/2 at 2 different places. So we now have 2 alpha equals pi over 3, 5 pi over 3. This is where that, I don't want to say magic happens, but this is where that trick comes in. You have to divide by 2 because you need to get alpha by itself. So even though you looked there to find where these occurred, you're technically multiplying it by 2 inside that argument to get those. So we have to divide by 2 to figure out the real angles. So that'd be alpha equals pi over 6, 5 pi over 6. And that's going to be your final answer. I worry that that little stamp is down there and I can't tell because I'm using just my iPad. So I'm going to move that answer up. So in case you didn't see it, pi over 6, 5 pi over 6. Okay, example 4 is complete. Okay, so I went ahead and filled out these half angle identities. You guys already had these down from when we did this in class. So the first day of 5.5, all we did was go through and put in all the identities. So this is from those. You guys should have them. So our next question says, find the exact value of 75. So what you're first supposed to do is look at your unit circle, and we see 75 is not on there directly. And so the way we can solve this is by these half angle identities. You can then know that if you multiply 100 or 75 times 2, you would arrive at 150. So we can create that 75-degree angle. So sine of 75 degrees equals sine of 150 divided by 2. And 150 is on our unit circle. So now we know that this value, 150 degrees, is in our second quadrant. Second quad. And so when you look at that, all students take calculus. That's where sine's positive. So as we do this, we don't need the plus or minus up here in this one because it already is we know it has to be positive. So I'm just going to write it out as the square root of 1 minus cosine of 150 all over 2. I've got to go to my unit circle and look at the value of cosine of 150. Okay, so I'm going to rewrite this as 1 minus minus the square root of 3 over 2, all over 2. In this next step, I'm going to do two things. I'm going to rewrite my 1 as a common denominator with the 2. So I'm going to write it as 2 over 2 minus, and then we have minus a minus, minus a negative. So that becomes a positive square root of 3 over 2. So I really didn't need all that giant. I needed some of it. I don't know what I am erasing it all. Let's go back. Here we go, divided by 2. We can rewrite this to make it just a little easier to see, maybe a little less confusing, as the square root of 1/2 times 2 plus the square root of 3 all over 2. I wrote really big again. So I'm going to go right here. We'll go like this. That gives me the square root of 2 plus the square root of 3 over 4. Okay, the first top part, when you square root it, it is what it is, right? There's nothing for me to simplify. But the denominator, when I square root it, it comes out as a 2. So I can rewrite this as the square root of 2 plus the square root of 3 all over 2. Or that 2 is not included because I already took the square root of it. And that's my final answer here. The next one up, I'm going to try my best to get to fit in here. I'm going to draw my little borders so I can at least keep my eyes on what I'm supposed to be doing. So as I look at this, once again, we see that 7 pi over 12 is not on the unit circle. But if we divide this by 2, or multiply this by 2, we have 7 pi over 12 times 2. That would create 7 pi over 6. And we see that is on our unit circle. So I'm going to start over here a little bit further this time. So I have tan of 7 pi over 12 equals tan of 7 pi over 6 divided by 2. Okay. We look here and we see that tangent for 7 pi over 6. Let's draw that arrow here, 7 pi over 6. 6 pi over 6 would be at pi. 7 pi over 6 would mean it'd be in that third quadrant. So again, all students take. Well, in that quadrant, we see that tangent is what's positive. So we're going to know we only need the positive version here. So if we go up to tangent, there are 3 tangent choices. It shouldn't matter which one you pick, just as long as you know it's going to be positive. I took the one that says 1 minus cosine theta over sine theta. So we look on our unit circle to find the value of 7 pi over 6 cosine. Sorry, I'm yawning, guys. So we have 1 plus the square root of 3 over 2 all over, and then the sine value there would be negative 1/2. Remember, when you divide by a fraction, it's the same thing as multiplying by the reciprocal. So we can rewrite this as negative 2 times 1 plus the square root of 3 over 2. We can do our distributive property. This gives me negative 2. When I multiply this over, though, it gives me negative square root of 3, which is my answer for this slide. Please let me know if you guys have any questions. Okay, so this one says, for number 7, solve the equation in the interval of 0 to 2 pi of, and then it gave us our equation. To solve this, we have to know that this is your half angles happening here. So we're going to be able to go through. Sorry, guys. This is people all messaging about e-learning to us as a math department. So if you hear that going off, I just silenced it. But we're going to have to substitute in with one of those identities, which we can do. So here we're going to be able to then write 2 times, and then we have our plus or minus the square root of 1 minus cosine theta over 2, quantity squared, plus cosine x equals 1 plus sine x. Okay, so we have plus or minus the square root, but the whole thing's being squared. When you square anything, remember that always makes it positive. So I can drop the plus or minus and the square root now, And I can just write it as 2 times 1 minus cosine. And then I put in a theta last time, but we can do x over 2 plus, and then we have cosine x plus cosine x equals 1 plus sine x. I'm able to rewrite this over here. I have where my 2's cancel, 2 in the numerator, 2 in the denominator. I now have 1 minus cosine x plus cosine x equals 1 plus sine x. Okay, so these two, plus and minus, go away. Then you're left with 1 equals 1 plus cosine x. Subtract over my 1. I get 0 equals sine x. Well, where does sine equal 0? Well, we know it's chicken strips, so it's going to be when my y-coordinate is 0. That occurs here and here. So 0 and pi are my answers. Okay, let's do the bottom one, 4. So 4 says we have to solve this as well. So I have our sine squared. I want to look for a way to relate this to cosine. So far what we've done is we see here we have a double angle. So it probably is natural to do more of a double angle formula. So I'm going to go here and swap this out to being one that looks like it. So 1 minus cosine of 2 theta over 2 plus, and then since this is already, I'll just rewrite it like this. I'll do it in 2 steps. 2 theta minus cosine of just regular theta equals 0. I want everything to have a common denominator, so I'm able to then just rewrite this as 1/2 minus cosine of 2 theta over 2 plus 2 cosine 2 theta over 2 minus 2 cosine theta over 2 equals 0. We can combine like terms. These terms are our like terms. I'm left with just 1/2 plus, and then in here I have cosine of 2 theta over 2 minus 2 cosine theta over 2. I'm going to multiply each half or each side by 2. I can distribute it through. That clears out my denominator, which is my goal. I have 1 plus cosine of 2 theta minus 2 cosine theta equals 0. Okay, this is still kind of ugly, isn't it? Okay, this cosine of 2 theta, I can swap that out with another formula. So we can go back and look at what cosine of 2 theta equals and pick one that kind of relates. Well, the one that's going to have cosine in it is going to be my best choice. So I can rewrite this as 1 . Sorry guys, I'm looking at what I'm doing to make sure I'm not leading us astray. Give me a minute to look at my identity real quick. Okay, sorry guys, I'm back. So I can replace this with 1 plus 2 cosine squared theta minus 1 minus 2 cosine theta equals 0. Common terms here are 1 and -1. They cancel out. I'm left with 2 cosine squared theta minus 2 cosine theta equals 0. We can factor out at 2. So 2 cosine squared theta minus cosine theta equals 0. Divide both sides by 2. I'm left with just cosine squared theta minus cosine theta equals 0. Once again, we can factor out a cosine because it's in both of them. Cosine theta equals cosine theta minus 1 equals 0. Each term can be set equal to 0. I'm going to move that over here. So we have cosine theta equals 0. And then we have cosine theta minus 1 equals 0. We can see where cosine equals 0. Well, cosine equals 0 at pi over 2 and 3 pi over 2. And then over here, we see that this is going to be cosine theta equals 1. Well, where does cosine of theta equal 1? Well, only equals 1 at 0. So here, if you wanted to write the shortcut, you guys could put the plus 2 pi in, plus or minus 2 pi in. Or what you can do is just do pi over 2 plus pi n. Because if you add pi to 2 pi n, you get 3 pi n. If you add pi again, that will give you the next one that would be equivalent to the 2 pi n. So plus or minus, you could really just say plus because we assume n is all integers. But I've been doing plus or minus, so we'll stick with it. So 2 pi divided by 2 plus or minus pi n. And then here, we do not account for pi. So this one has to be plus or minus 2 pi n. And that will be our solution. So we have this one and this one. Okay, this is where I'm going to leave off for today. This is a 20-minute video. Try some of your homework. Have a good day.